calculate the sum of squared deviations, or SS for short, for the following population. And my population scores are 2, 2, 2, and 6, so very small population. I'm going to put those values here, and I'm going to work out using both formulas for sum of squares. I'm going to work out the result, the sum of squares. Now the first one, this is the computational formula. This is the sum of my squared deviations from the population mean. So this is the computational formula. Or sorry, actually that's not the computational, that is the definitional. Down here is the computational. This is the one that I prefer to use. It is the sum of x squared minus sum of x in brackets over n. All right, now let's start off with the definitional. I need to first of all find my mean, and the mean is the sum of x over n. So I need to know my sum of x. So 2 plus 2 plus 2, that makes 6, plus another 6, that makes 12. So it's going to be 12 over 4. So 12 divided by 4 is 3. So when I do my first column to make my deviations, I'm going to be subtracting 3 from each one of these. The reason that this is going to be my first column is because of order of operations. Anytime you're performing a formula, you have to follow these steps. You have to look for brackets first, and we do have brackets. In our formula, inside the brackets, we have a deviation. So that comes first before I look at anything else. I'm not going to look at squaring anything or summing anything up. I first of all have to subtract 3 from each one of these. 6 minus 3 is 3. Okay, so that's brackets. Now what comes next is exponents, and so that does mean that I'm going to square things next. For example, I'm going to have negative 1 squared is 1, and so on. But I want to show you what happens when I add here. Negative 1 plus negative 1 plus negative 1 makes negative 3, plus positive 3 makes 0. This column here, your deviations, when you sum up your deviations, you will always get 0 if things are going well with your calculations. So using the definitional formula takes a little bit longer, but it does give you this ability right here with your very first set of calculations to check and see whether or not you're getting 0. So we've done that. We can move on now. We're confident that these are all the right answers. After this, we're on our own. So there's no other checks I can perform after this. But 1 squared is pretty simple. 3 squared is 9. And the only thing left for me to do, now that I've done brackets and exponents, seeing as there's no division, no multiplication, I just have to do my addition, which means I add up this column, and that gives me my sum of my squared deviations. 1, 2, 3 plus 9 makes 12. The answer is 12. So the answer is going to be C, 12. That's what I get from the definitional formula. With the computational formula, I'm going to get the same thing, but I'll show you that with the computational formula, it all goes a little bit faster. 2, 2, 2, and 6. Once again, for the computational, we need to know the sum of x. So that's one column to get this. The other column is going to work on getting my x squared. If I square each one of these, 2 squared is 4, 2 squared is 4, and so on. 6 squared is 36. This will give me everything else that I need. 4, 4, and 4 makes 12, plus 36, that makes 48. My sum of squares is the sum of x squared minus the sum of x in brackets squared over n. I'm going to put in the 48, and then it's going to be 12 squared, and I had 4 values. 12 squared is 144, and 144 divided by 4 is 36, so this is going to be 48 minus 36. This gives me 12. So here is my sum of squares that I got using the computational formula. It, of course, it agrees with what I got with the definitional formula, but I was able to do this in just 1, 2 columns, as opposed to having to do 1, 2, 3 columns. The computational formula is a little bit faster. It probably doesn't seem like much here, but if you have a very large list of numbers, it's going to take even that much more time to have a third column. So the benefit of the computational formula is that it is faster. But with the definitional formula, you're able to do this little check. You can check with that column whether or not you're on the right track. So this one is a little bit safer. So you decide which one you prefer.